Hi everyone, Cameron here. Testing has always been an important part of the development process. Traditionally, specifications were formulated, the code was developed, and finally, the code was tested. Any errors or changes needed would then result in further development work. Test-driven development, also known as TDD, turns this process around by taking the specification and turning them into tests. These tests are written in the code and drive the development process. Although this can feel counterintuitive at first, it comes with a number of benefits. TDD can result in detection of errors sooner, and even more importantly, show problems with the specifications. TDD can also result in cleaner, more modular code, as error cases in edge conditions are dealt with upfront. Let's look at the basic strategy for test-driven development. First, write a test for the functionality you're about to develop. This test should fail because you haven't written the functionality yet. Run the test. If it fails, that's good. It shouldn't pass yet. If it passes, you should add some more assertions to make it fail. In other words, check whether a condition is true or false. Once you have a test that fails, write the most basic functionality to make it pass. Then add another failing condition. Write the code to make that condition pass. Keep the cycle going, a red bar for a failed test, and then a green bar for a pass test, until your feature is complete. Make sure you didn't leave out any edge cases or failure conditions. You shouldn't write all your test conditions in one test. It's best to have many individual tests that test different conditions. This will help you identify which areas fail if your coding changes results in another failure in a different area to the one you are working in. In Java, TDD is primarily done with the library JUnit. The JUnit library provides numerous useful features to achieve TDD, or any other testing methodology you might choose to pursue. To begin with, create a class that would hold all your test methods. Then create a test. Simply write a method and use the @test annotation. In your IDE, you will be able to run the entire test class or a single method. Within the tests, you will have access to various assertion methods, checking for equality, null status, or many other common checks you might like to do. You can even check if a certain exception has been thrown. Unit testing is a strict form of testing where only individual classes and methods are tested. This means our tests are more focused and have finer granularity. But it also means that we must use methods in such a way that all the dependent classes are under the control of the tests. To do this, we can create mock dependencies. These are classes that extend the interface of the dependencies. Suppose you want to test how your method will respond if a call to a dependency method results in an exception. How could you get this condition to occur in your test? In your mock dependencies, you can create a method that simply throws the exception. Now you know how the code you are writing responds to this occurrence. Of course, it is a fair amount of effort manually writing all of the mock dependency classes that you might need for every test and for every condition you might wish to test. This is where mocking frameworks come in. The most common Java mocking framework is called Mockito. Mockito allows you to declaratively state that you would like a mock class that has certain outputs for certain inputs. For example, you can define what response you would like if a method is passed a 1 or if it is passed a 2. Or you could say, I don't mind what input is given, but when the method is called for the 5th time, I would like this response. It allows you to be totally flexible and specific about the behavior you want only in a few lines of code. Mockito also allows you to create assertions based on the number of times a method is called, or the arguments it was called with. Behavior-driven design, also known as BDD, takes the concept of TDD and makes the link between specifications and the test concrete. In fact, BDD allows the specifications to become the tests. By using a domain-specific language for writing the requirements, these requirements may be run as tests. The general process is that a business sits down with the quality analysts and developers and writes the specifications in BDD DSL. Because the specifications have to be formalized to such a high degree up front, many of the issues are ironed out in the beginning. Then the tests can be run as the developers implement features. Features are implemented, so the test results show their progress. At the end, you have working features as well as a complete specification to the product. BDD and TDD can go hand in hand and be complementary testing methodologies. TDD primarily helps the developer to write his or her code, whereas BDD is great for having regression tests that keep the team on track. There is no one-size-fits-all approach for testing. The approach depends on the situation. It could be more formal or less formal with different levels of coverage. The most important thing is that testing is being done. No code should be considered complete unless tests have been written for it. This brings us to the end of this lesson. Thanks for joining me. Remember to post your questions and comments to the Noroff forum.